lesson, and today I have a different thing to share, and of course in a different subject, and this is chemistry. And I want us to actually have a chance of looking at something that is so important, and as well it is actually an industrial process. If I can be able to have a keen observation, I can realize that the following flowchart that I'm actually sharing is actually one that has been extracted from a topic that we always refer to as sulfur and its compounds. So to be brief, I'm going to use this flowchart to just introduce some concepts in as far as this area is concerned. If you can be able to observe keenly, you can be able to see some of the following things that can give us a hint in as far as us being able to actually conclude that this one has been extracted from sulfur and its compounds is concerned. If I can have sulfur here, then I can be able to have the SO3 here, and I can be able to have the H2SO4. Those three are clearly showing me that this must be a topic which revolves around sulfur and its compounds. This flowchart is moving in this direction in as far as the arrows are concerned. And that tells you that this is the starting point and this is the end point of this flowchart. It is an industrial process. It is an industrial process that gets used to manufacture H2SO4, that is sulfuric acid, or also referred to as sulfuric 6 acid. If you look at this, you can be able to understand that the information that you are going to get from my presentation is going to help you to understand how sulfuric acid or sulfuric 6 acid gets manufactured on industrial scale for commercial purposes. Now, always, if you get such a chance of getting such a question in any examination you may come across, please always be able to know where the process starts and where the process ends. And I've said this is the starting point of the process as per the way we are seeing these arrows, and this is the end point of our reaction. So if I look at this, I can be able to understand that sulfur and something X gets fed into a burner. It can be a kiln where temperatures are high to facilitate the reaction. And of course, temperature becomes one of the factors that can favor a reaction in as far as speeding up the reaction is concerned, as we shall be able to explain that in detail. So we are actually supposed to ask ourselves, sulfur has to undergo combustion with something else. Industrially, whatever happens is that always we need to get a gas referred to as SO2. This one is referred to as sulfur dioxide, or it is also able to get called sulfur 4 oxide, SO2. So industrially, our main aim is to first to get sulfur dioxide or sulfur 4 oxide, which is SO2. In as far as structure and bonding is concerned, you can be able to understand why we have 1 sulfur and 2 oxygen atoms. Great. And in that case, you can be able to understand that the sulfur must be able to be burned with something else to get the sulfur dioxide I'm talking about. So that means we need to have the sulfur, in this case, undergoing combustion. And now there's actually a yellow powder. Sulfur is yellow. This yellow powder undergoes combustion. That is to mean it has to get mixed with oxygen to give you sulfur dioxide. So the sulfur dioxide can be obtained when sulfur, a yellow powder, or solid rather, gets mixed with oxygen, and it gets allowed to burn in a burner. where the temperatures are actually well enough to facilitate the reaction. So that gives us sulfur dioxide. So this is a gas, and this one is also a gas. Good. It's a colorless gas which has the ability to actually cause the choking, such as what we call a choking and irritating smell. It is actually an acidic gas. That is to mean when it gets dissolved in water, it actually gives an acidic solution that can be able to turn a moist blue litmus paper to red. So this one is actually an acidic gas with a choking and irritating smell, which is denser than air, and then it gets collected by downward delivery or upward displacement of air. Good. Downward delivery or upward displacement of air. Downward delivery. The gas delivered downwards shows that it's actually denser than air. So it gets delivered downwards, then displaces the air inside this gas jar upwards. That's why we say downward delivery of the gas or upward displacement of the air inside this gas jar. That's how sulfur dioxide or sulfur oxide gets collected. Now moving forward, we now have sulfur dioxide here. So that is actually to say that the sulfur here combines with the oxygen gas. Now what do we get at the end of the day? We have the sulfur dioxide. Good. So the sulfur dioxide gets taken to chamber 2. This chamber 1, this chamber 2. See, in this chamber we've been given cleaner plus Y. What could Y stand for? So the air is allowed here. We have the cleaner and Y. You see, possibly if you take sulfur dioxide, let me just come back to the question. If you take sulfur dioxide, then you dissolve in water. Unfortunately, this is a gas and this is a liquid. When such a reaction takes place, what are we going to have? We are going to have H2SO3. What is this? This is actually referred to as sulfurous acid or sulphuric acid. Look at this. This is sulfur dioxide getting dissolved in water, you see, with an aim of forming this H2SO4. But this one does not get formed because when SO2 dissolves in water or gets dissolved in water, it gives H2SO3, which is sulfurous acid or sulphuric acid. So solely, industrially, we can't use sulfur dioxide to form H2SO4. That's why at this point, the sulfur dioxide, SO2, must further be able to get oxidized. And when you talk about air, everybody knows air is a mixture of gases. But now, the active part of air that can be able to take part in a chemical reaction, majorly, is oxygen. So as much as we are allowing air inside here, this is not purely oxygen. It's actually a mixture of gases. But now the active part of air that is going to take part in this reaction is oxygen. So the oxygen gets allowed into this chamber 2. The sulfur dioxide also gets allowed into this chamber 2. They are going to react to give us a product. Now, they have said air, now a mixture of gases. Majorly, we have to actually consider oxygen and not that mixture of gases like nitrogen 78%, carbon dioxide 0.03%, and the other gas. We have to consider oxygen and not oxygen getting mixed with other gases which are not going to take part in the reaction. Because here, carbon dioxide is here, nitrogen is here, water vapor is here, dust particles are also here. They all form what we call components of air. We don't consider them so much. We don't talk about the noble gases which are actually unreactive or inert or inactive or rare. So we have to consider oxygen. So when you consider oxygen, the oxygen gets taken into this chamber 2. The sulfur dioxide also gets taken into this chamber too. So you have the oxygen coming in, the SO2 coming in from this chamber. And remember, by the way, let me just go back here and tell you something. If you come here, you should note that sulfur dioxide, SO2, cannot only be able to get obtained by burning sulfur in air. So this is obviously air. Talk about air, I have to refer to oxygen. So X is probably air or oxygen. So the sulfur gets combined with air or oxygen, to be precise, to form sulfur dioxide. So the sulfur undergoes combustion in the burner. The temperatures are conducive here to ensure that the reaction gets sped up. See, how does temperature affect a reaction? When temperatures increase, the particles of the reactants, so in this case, the particles of the sulfur and the particles of oxygen, now the molecules, are able to actually absorb heat energy because of the environment being able to get heated. When they absorb heat energy, the kinetic energy of the particles increase, and the kinetic energy of the particles increasing favors what we call a rapid, continuous, and random motion of those particles. So as the particles move continuously randomly, that means that favors what we call successful collisions. So when there are successful collisions, that means the reaction gets sped up, the process gets sped up, products get formed within a very short period of time. It saves on time. The process generally, as far as this industrial process is concerned, gets as well sped up. Good. The end product, the H2SO4, can get formed within a very short period of time. So to actually introduce something different, SO2, that is it, SO2 can also be formed from burning sulfides. So when sulfides get burned, they also give SO2. So SO2 can also be obtained apart from burning sulfur and oxygen in air by burning also sulfides. For example, if I can take this example, I can say iron 2 sulfide is a black solid, see, can be able to get burned in air. That is a solid, it's a black solid. Then you have oxygen, it's actually a gas.